Welcome to the UG students. Now we are going to that of the MSc entrance examination Parikha exams CUET solution 2022 for the organic chemistry, and this is very important also to that of the NEET and JEE guidelines. Now we are going to that of the acid strength problem. The first problem is that of the acid strength problem. Here the different type of the chloroacetic acids are used for their acid strength. With increasing the chlorine substitution on the carboxylic acid, the acidity of the carboxylic acid increases. This is due to that of the stability of the conjugate base after the deprotonation. Here with increasing the chlorine substitution on the alpha position of the carboxyl group, the acid strength will increases, and the problem in the given problem is that the D is higher acidic compared to that of the C and B and A. Here the butanic acid is lower acidic compared to that of the acetic acid. So the order is that D greater than C greater than A greater than B. We know that with increasing the electronegativity of the alpha position of the carboxylic acid, the acid strength will also increases and the pK value will also decreases. Here the acetic acid has higher pK value, means 4.76, but chloroacetic acid has lower pK value 2.66, means chloroacetic acid has higher acidity compared to that of the acetic acids. And this problem is given from that of the Claydon books, where the acidity of the different type of the cyclopentane fused derivatives are given. Here in this case of the fluoridine, that is the pK value is 11, but in case of the Indian derivative, the pK value fluorine derivatives means the pK value is 22.8. Here with increasing the benzene substituents, the resonance effect, the conjugate base becomes stabilized, so the acidity of the fluoridine is higher and the whole system becomes planar due to that of the binding mode. But here the phenyl group is opened, so the sterically hindrance, the resonance effect is not properly work, so the conjugate base is not so stable, hence it has lower acidity compared to that of the fluoridine. Next we will go to that of the exothermic versus endothermic problem. We know that in case of the exothermic reaction, the product is more stable than that of the reactant, but in case of endothermic reaction, product is less stable than that of the reactant. This is the pictorial diagram for the exothermic reactions and endothermic reaction. In the given problem, the potential energy diagram shows that the reactant is first converted to the intermediate, and then this intermediate is going to go to that of the product. Here the intermediate is less stable than the reactant, so the first step is endothermic, but in the second step intermediate is less stable compared to that of the product. Here the product is more stable, so the second step is the exothermic. So the endothermic and exothermic is the right option. Now we are go to that of the halogenation reactions. In case of the halogenation reaction, the reaction go through the photochemical conditions. In presence of the radical intermediate, here H nu is used, the chlorine is radical is formed, and the chlorine radical abstract the hydrogen atom of the propane or butane system and produces the either 2-degree radical or the 1-degree radical. We know that 2-degree radical is more stable than that of the 1-degree radical, so the 2-degree halide compound is more stable, more formed compared to the 1-degree halide compound. So in the given problem is that when the chlorination of the N-butane occurs in presence of the photochemical condition, we get that of the 2-chlorobutane as the major product. Now we are going to that of the stereogenicity and chirotopicity of problem. In the statement 1, any molecule which has a plane of symmetry or a center of symmetry is achiral, means the criteria for the optical activities that avoid of the sigma, I and Sn symmetry is the molecule becomes optically active. So in the given examples, we show that the plane of symmetry is present in the molecules, and though the molecule has a chiral center, but the plane of symmetry is contained, so the molecule is overall optically inactive. Again, compound that contains stereogenic center but are themselves achiral are also called mesocompound, means if this compound 2,3-dihydroxy glutaric acid, this center is stereogenic as the after exchange of the hydroxyl group with that of the hydrogen group, produces the new isomer. This is called the stereogenic, means these 3 and 4, these are the stereogenic compound, means the after the exchange it produces new isomer, but the compound overall is optically inactive due to the presence of the plane of symmetry. Here we get that of the some examples where the molecule contain the chiral center but it is optically inactive due to that of the enantiomeric mixture, that is the flipping inversion, and we know that this compound is called invertomer. Here is the examples where the molecule does not contain any chiral center but it is optically inactive. Sorry, this is the optically active molecules. This is the optically active molecule, but it has no chiral center. That is the avoid the sigma I SN symmetry for that molecules. Now we are going to that of the major product of the following reaction is that of the in case of the sodium amide, in case the liquid ammonia, the hydrogen and Br molecule is eliminated from the system and produces the benzene intermediate, and this benzene intermediate can add the amine molecules. Amine NH2 minus produces the two isomer. One is the para isomer, another is the meta isomer. Here the para isomer is less stable and meta isomer is more stable. That is the meta product is formed as the major amount, as the methyl group has the plus I effect. So the negative charge with increasing the distance is more stable. So the meta isomer is formed as major amount and the para isomer is formed at the minor amount. Now the consider following statement. We know that the HBr addition, in case of the HBr addition, the Markovnikov addition will take place in case of the unsymmetrical alkene and produces the two carbocation. One is the 2 degree carbocation, another is the primary carbocation. We know that the 2 degree carbocation is more stable, so the Markovnikov product is formed at the 2 bromopropane is the major amount and the 1 bromopropane produces as the minor amount, as the peroxide group is present in the reaction. So the anti-Markovnikov product is formed as the major amount, or in case of the HBr addition, the Markovnikov product is formed as the major amount. And we know that the vinyl group, vinyl halides is not stable by the elimination of the Cl group and produces the carbocation, and this carbocation is not so much stable as the positive charge present on the sp2 carbon atom, and again the SN2 nucleophilic addition is not take place, that is the linear geometry is not maintained, so the SN2 reaction is not take place for the vinyl halides. We know that the bridging head double bond at the bridge head position is very much unstable, so the elimination is not occur for that substrate. So the statement A, B and D is the correct, but the E2 elimination at the bridge head position is easy to occur. This statement is wrong. Now we are going to that of the pinacol and pinacolone rearrangement. In case of the unsymmetrical diol derivatives, we know that the pinacol-pinacolone rearrangement take place in case where the hydroxyl proton is protonated to produces the carbocation, and then this carbocation, after the formation of the carbocation, the alkyl group is migrated to the carbocation and produces the carbonyl derivative. Here the this is the tosyl chloride in presence of pyridine. There are two type of the hydroxyl group is present, but the sterically less hindered hydroxyl group is tosylated to produces the carbocation, and after the migration we get that of the product D. Now we are go to that of the Claisen condensation reaction. In case of the Claisen condensation reaction, there is an equilibrium between that of the alkyl acetate with that of the product beta diketone product, that is the ethyl acetate. Suppose alkoxy group is ethyl, so it becomes ethyl acetoacetate, and this 1,3 diketone is formed by the equilibration reaction. Here the first step is go to that of the left hand side, but the last step is the go to that of the forward reaction in the presence of the excess base. In the Claisen condensation, excess base is required to move that reaction to that of the forward direction. These are the examples where due to the stereochemical relations between the two isomers is the homomer. After the conversion into the Fischer projection, one identical compounds are formed, so the relation between these two compounds are homomer. Now the stereochemical relation requirement for the E2 elimination is that the two leaving group must be present in the anti-periplanar orientation. Here the base is abstract the hydrogen atom and leave the X group and produces the alkene. the stereoelectron requirement for the E2 elimination is the anti-periplanar geometry. So the anti-periplanarity is the main requirement for the E2 elimination reaction. Now we go to that of the stability of the different conformation. In case of the ethylene glycol always present in the skew conformation, means this is the Gauge conformation, it becomes stable. Than that of the staggered conformation, means the anti-conformation. In case of the Gauge conformation, the intramolecular hydrogen bonding effect stabilizes the Gauge conformation, but here the anti-conformation is less stable. Here no steric interaction is present, so the Griffin pollen A is true but R is false. In case of the substitution reaction, we know that the methoxymethyl chloride is easy to occurs for the SN1 reaction due to that of the field lone pair of the oxygen atom can overlap with that of the vacant orbital of the carbocation and produces the carbocation intermediate. So the reaction must go through the SN1 reaction, and these are the problem taken from that of the Claydon books, where that the different type of that of the alkyl halides where the show the different rates. Here the perennial halides, this is the example of perennial halide, shows the highest rate of the SN1 reaction compared to that of the phenyl substituted halide, and this is very important for the to determine the rate of the different type of the halides. Now we are going to that of the polarity effect of that of the substitution reaction. We know that with increasing the polarity, the SN2 reaction, or consider the following reactions involving SN2 mechanism, but with increasing the polarity will accelerate upon increasing the polarity, means if the product is more polar, then the reaction rate becomes more enhanced compared to that of the starting material. Here the polar solvent is polar, so the product is more stable compared to that of the reactant, so the B option is the correct option. With increasing the polarity, the activation energy required for that of the substitution reaction is lower, and hence the reaction rate is accelerated. And these are the problems where there are different type of the two statement. One is the statement 1 that can be stabilized by zero resonance. This is true because the nitrogen lone pair can interact with that of the vacant p orbital and produces the stable carbocation. The formal charge concept is here wrong. The carbon and nitrogen are +1 and -1 respectively, but if we calculate the formal charge on that of the substrate, here the carbon atom contain the +1 formal charge, but nitrogen atom contain the -3 formal charge. So the statement 2 is wrong. That is, the statement 1 is true but statement 2 is false. Now we are going to that of the Z2 phenyl butane with bromine leads to that of the 63% anti-addition and 37% syn addition. That is, the reaction must go through carbocation intermediate. Here the bridge brominium ion formation for that of the substrate is very unstable because the carbocation can be stabilized by the pi electron conjugation of the phenyl ring. So we get that of the syn plus anti-addition product. So the statement D is only the correct. That is, brominium ion is less stable than the corresponding open chain carbocation intermediate. Now this video is ended. Now we are going to that of the next session, next solution for 2024. Thank you.